Superposition does not imply entanglement. Particles forming a joint state does not necessarily mean they are entangled. They could simply be in a separable superposition of their individual states. Entanglement requires that the particles' states are fundamentally correlated in a way that cannot be separated into independent states. Think of two dancers. Independent superpositions. The dancers are on entirely separate stages, each performing without awareness of the other. No shared stage or connection. The superpositions of dancer A, spin and wave simultaneously, and dancer B, jump and clap simultaneously, are not connected. Separable state. The dancers are on the same stage, a joint state, but they are performing their routines independently. Their movements don't influence or depend on each other. In a separable state, dancer A and dancer B, or particles A and B, do form a superposition as a system, even though they are dancing separately, i.e., their states are independent. This is because their joint state involves a superposition of their individual states when described together. The combined quantum state of A and B can be written as the product of their individual state psi equals ket phi A tensor ket chi B. Here, A is in a superposition described by ket phi, and B is in a superposition described by ket chi. When we write out the product explicitly, the joint state as a whole is still a superposition of the possible outcomes for both particles, even if the individual particles are independent. Analogy: superposition of two independent dancers. Two dancers on the same stage are performing independently. Imagine. Dancer A is independently performing a routine that involves two moves at once, e.g., spinning and waving, represented by ket phi A equals 1 over square root of 2 times ket spin plus ket wave. Dancer B is independently performing a routine that also involves two moves simultaneously, e.g., jumping and clapping, represented by ket chi B equals 1 over square root of 2 times ket jump plus ket clap. The joint state is the tensor product of their individual states. Ket psi equals ket phi A tensor ket chi B equals 1 over square root of 2 times ket spin plus ket wave tensor 1 over square root of 2 times ket jump plus ket clap. Expanding this gives ket psi equals 1 over square root of 2 times ket spin, jump plus ket spin, clap plus ket wave, jump plus ket wave, clap. This is a superposition of all possible combinations of moves between the two dancers. Spin plus jump, spin plus clap, wave plus jump, wave plus clap. Even though each dancer is performing their routine independently, the joint state of the system is in a superposition of all the possible combinations of their moves. This illustrates that forming a joint state inherently involves a superposition, even in a separable state where the two particles, or dancers, are not entangled. In a separable state, the two particles or dancers form a joint superposition of all possible outcomes, even though their individual states are independent. The fact that they share the same stage, joint system, ensures that their states combine mathematically into a superposition. However, this does not imply entanglement, as their individual states remain independent of each other. Entangled state. The dancers are not only on the same stage but are performing a choreographed routine where each move of one dancer is correlated with the others.